Hello everyone, I hope you're doing well and welcome back to Life Technologies YouTube channel. So this is another episode of our Huawei Lab simulation series, and in this episode we'll be discussing how to implement in the ASBGP MPLS IP VPN option C with route reflectors. So in our previous episode we've demonstrated how to configure option A, option B and option C, where we are just establishing BGP peering session between the PEs in different autonomous systems. But all the previous options, they are not scalable enough. You can see that when you are doing option A, you need to establish so many VRF to VRF BGP peering session. You need multiple interfaces or multiple sub interfaces between the two different nodes. You also have to do end-to-end configuration for the VRFs. So you need to configure VRFs on the PEs and the ASBRs on different autonomous systems. Option B allows us to do MPLS between the SBR, so we do VPN v4 peering between SBRs, but this one places a higher requirement on the SBR because they have to maintain customer routes. So that's why we require option C, that is more scalable. So option C, I've mentioned that we have two options. So if I just go to my topology, with option C we have two options. The first option is where we do BGP peering session between the PEs. So we'll establish BGP peering session between P1 and P2. And given that we have multiple PEs on this topology, it means you also need to establish BGP peering session between P1 and P4 for them to be able to exchange routes. Similarly, we'll have to establish BGP peering session between P3 and P2 and also P2 and P4. And whenever we need also the local communication between these routers, we also need to establish BGP session between the two PEs in the same autonomous system. So you can see that we have a kind of meshed BGP peering session between PEs in different autonomous system, which makes it not scalable enough. So that's why we have in the ASBGP MPLS IP VPN option C with route reflectors in place. So with route reflectors, it means you can see that in this topology, we have route reflector 1 and we have route reflector 2 in different autonomous systems. So with option C, with route reflectors, we only need to configure BGP peering session from RR1 to RR2. And then these RRs will be in charge of advertising routes within the autonomous system. So whenever we need routes to be advertised, we'll have routes shared between the RR and the PEs in the local autonomous system. Similarly to this side, we have route exchange between PEs and RRs. And it's very easy to scale the network. Whenever we have a new PE router coming in, for example, if we have a new PE router coming in, we only need to, let me redraw it. If we have a new route reflector coming in, for example, in this location, we only need to peer the PE with the RR, and that is it. The RR will now be in charge of advertising the route to the PE, and now the PE should be able to advertise the same routes to the CE in the same VPN instance. So you can see that with option C, with the route reflectors, it's very scalable, it's very easy to implement and manage, and it's the most preferred solution when it comes to the INDAS BGP MPLS IP VPN options due to its scalability. So to start us with, let's look at some basic features of option C with route reflectors. So the basic features of option C, we have mentioned that it's scalable. The route targets are globally significant, so you always have to configure unique VPN targets for different VPNs because they are globally significant. We are running MPLS between the SBR, so we'll activate MPLS on the interface connecting SBR1 and SBR2. We configure VPN v4 peering between RRs. So I've mentioned that for this setup, for the BGP configurations, for the MP-BGP, the first thing that we do is we have to have BGP VPN v4 peering between our RRs. So we'll do VPN v4 peering between the RRs in the different clusters, and then we also need to establish BGP VPN v4 between RRs and the PEs in this cluster. So we'll do BGP VPN v4 peering between the RRs. And also between the PEs and the RRs in the same cluster. So once we have done this, now we are able to propagate routes all the way from the CE, because this CE will send the routes to the local PE. The PE will send the route to the local RR, and then the RR will send the route to the remote RR. Once the routes are on the remote RR, they are propagated, or this is acting as the route reflector for these PEs. So they will reflect the routes to the local PEs, and now the PEs can filter the routes based on the route target and advertise the routes to the CEs in the relevant VPN instances. So you can see that this is very easy and it's very clear even on the traffic flow. So another feature that we have is we don't do VRF configurations on the ASBRs. So we don't do any VRF configurations on the ASBRs and RRs. The VPN configuration are only done on the PEs. So we only configure VPN instance on P1, P2, P3, and P4. No VRF configurations on the ASBRs, the PE, and the route reflectors. BGP LU is configured between SBR. So we are configuring BGP label unicast between the SBR so that they are able to exchange label routes and also apply labels whenever they are exchanging routes. And then we have end-to-end LSPs established between PEs. So we have end-to-end LSP. We'll have an LSP from P1 to P2, P1 to P3, P1 to P4. So we have an end-to-end LSP when we are forwarding traffic from one PE to the other. So these are the key features of option C, scalable. Route targets are globally significant. MPLS runs between the SBR. We configure VPN v4 peering between the route reflectors. We don't do any VRF configurations on the SBRs and route reflectors. We only configure VRFs on the PEs. And then BGP label unicast is configured between SBRs. Of course, we have MPLS configured between the SBRs, and end-to-end LSPs are established between the PEs. So these are the key features of BGP MPLS VPN option C. So if you want to understand option A, option B, and option C, where we are doing PE to PE peering, you can check out our previous episodes. They will help you to understand how and why we need option C with route reflectors. So we have videos on our channel. We have already demonstrated even on how the packet flows from CE to CE. So you can check out those videos. And just a reminder that if you are watching this video and you are yet to subscribe to our channel, kindly hit that subscribe button to support us and also to stay tuned in for more upcoming videos. So I have shown you the topology. You can see that from the topology we have, let me use the snippet. So this is the topology that we are using for our lab simulation. We have two autonomous systems. We have S100, we have S200. S100 and S200, they are connected through SBR1 and SBR2. So those are the area border routers. And we have P1 and P3 in S100, and then we have P4 and P2 in S200. So we have different CEs in different VPN. We have VPN A and VPN B. You can see that this one is in VPN A. This is VPN B. This is also in VPN A. So we need to configure these VPNs facing customers. And then for communication between PE and CE, we'll be configuring BGP. So we have eBGP configured between PE and CE. For IGP communication, we need to configure OSPF in different autonomous systems. So we'll configure OSPF process 10 in S100, and we also configure OSPF process 10 in S200. And for the BGP configuration, I mentioned that we need to do eBGP configuration, MP-BGP configuration between RR. So we need to establish BGP configuration between RR1 and RR2, and then we can do IBGP, MP-IBGP between the RRs and the PEs. So those are the configuration that we'll be doing. And remember, we also have to configure MPLS and LDP and we'll be configuring step by step and doing the verification so that you are able to understand how to configure and troubleshoot MPLS IP VPN option C on Huawei routing devices. So this is the setup in ENSP, and we can now start our configurations. So the first step of our configuration is to configure the sysname as usual and configure interface IPs on the different routers. So you can see that we have a sysname configured to the device. Always give a meaningful name. And then we have interface configuration. So we create loopback IPs and assign the necessary IP address. We also configure IP addresses on the interface connecting different devices. So we'll start by configuring P1. So nothing is configured yet. We will do the configuration step by step and also do the troubleshooting. So we'll start with P1. P1, I will undo terminal monitor. And then we need to be in the configuration view and paste. So this is for P1. Let's check on P3. So P3, we also configure the sysname and configure interface IPs. So I'll go to P3. Let me undo the terminal monitor so that it doesn't disrupt so that is it for P3, and then we can go ahead and configure P01. So P01, the provider edge router interconnecting different nodes in our topology. P01, this is P1, undo terminal monitor. Then I'll paste these configurations. This is okay. The next step is to configure SBR1. So SBR1 has two interfaces, one to P01 and also the other one to SBR2. And whenever you are doing this configuration in a production network, you always have to provide interface descriptions. So the next one is RR1. Let me check where is RR1. RR1 is here. Undo terminal monitor. Then you paste. So this is the first step of our configuration, just sysname and the host name and the interface IP, the loopback IP, and the back-to-back connection between the different routers. So we can do some verification. I can run the command display IP interface brief. You can see that RR1 has a connection to this 002, and we can ping .6. So let me rerun display IP interface brief. Then I can ping 20.20.20.6 to verify that our point-to-point configuration is okay. That is okay. I can also do similar configuration, similar verification on P3. Let me clear the screen first. Display IP interface brief. See that we have 001 connecting to our P router, so I can ping 20.20.20.2. That is okay. And finally, we can also do verification on P1, the one with many interfaces. I'll clear again, display IP interface brief. So let's verify ping 20.20.20.4. That is okay. .1, it's okay. Then .7, it's okay. Finally .3. So this one verify that our configuration, our basic interface configurations are okay. We can see that we can ping point-to-point interfaces between the different routers. So the next step is to now configure OSPF. So remember, when we are doing a BGP, will be using the loopback IP to configure BGP between the different routers. So we need to ensure that we have reachability between different nodes. That's why we need to run OSPF in this autonomous system. Then we also need to do similar configuration in AS200. So OSPF is to ensure that we have reachability between different nodes, and then we can now go ahead and configure BGP on top of it. So for OSPF configuration, the first thing that we always have to do is to configure the router ID. It's always recommended to manually configure the router ID. Once you've configured the router ID, you can now activate the different networks in the relevant OSPF area. So we are all in area 0, so we'll advertise the loopback IP and also the point-to-point interfaces between the different routers. So starting with P1, these are the configs that we need to run. So we are configuring OSPF 10, that is the process ID, and then we are activating on loopback 1.1.1 and then point-to-point 20.20.20.4. The wildcard mask is 001. So I'll go to P1. So for P1, where is P1? P1 is here. Do terminal monitor again. System, let me clear the screen so that it's clear. Then I'll paste, quit. So you can display this to view the configuration that we have. That is okay. I'll go ahead and configure P3. So P3, these are the configurations. P3, it's here. I'll clear the screen again so that you are able to see clearly what we are configuring. Display these are the configurations. Next step is to configure P01, our provider edge router. So this one we are advertising multiple networks because this is the router that is interconnecting different other routers. You can see that it's connecting to RR1, to PE03, to SBR, and also to P1. So on P1, display this, we are good to go. Then we need to configure SBR1. So where is SBR1? It's here. System view, clear, then paste. You can see that our OSPF peer relationship between SBR and P is coming up. We are now in the two-way state. Then finally we need to configure RR1. So on RR1, these are the configs. So on RR1, these are the configurations. So once we have finished OSPF configuration, we need to verify our OSPF peering status. So display OSPF peer brief. You can see that we have an OSPF peer relationship to this P router. You can display OSPF route. You can see that we have been able to learn some routes. Let's see whether we can ping any router. So if we try to ping 1.1.1, we are able to ping. Try to ping the RR, which is 7.7.7, it's okay. Ping SBR 3.3.3, it's also okay. And then we can also ping the P router 2.2.2, which is okay. So this one means our SPF configuration on P03 is okay. We can check on P1. Let me clear the screen again. So on P1 display OSPF neighbor, you can see that we have multiple OSPF display OSPF peer brief. You can see that we have 4 OSPF neighbor relationship. They are all in full state. Display OSPF route. You have the routes finally on RR1, and we also need to check on the SBR. Display OSPF peer brief. We have the peer relationship, display IP routing table. I mentioned that we need to ensure we have reachability from the RR to the P routers. So I can ping 1.1.1 on the P1 and then 10.10. This is on P3, so we are okay. Finally on SBR1 can see that from the log messages, our OSPF relationship is up. Display OSPF neighbor. Display OSPF peer brief. We have the peer relationship. Display OSPF route. We try to ping 7.7.7. That is okay. So we have reachability in S100. We can be able to communicate from different nodes too. So we can communicate from PE to the RR, we can communicate from PE to SBR, from PE to SBR. So that one confirmed that our configuration for SPF protocol are okay. Our IGP is well configured. So we go to the next stage of our configuration. We now need to do some basic configs in S200. So we'll start by configuring the interface IPs, starting with PE2, our provider edge router 2. So for provider edge router 2, this one, I always prefer to undo the terminal monitor. Then we can configure the parameters. Next, we need to configure PE4. Check where is PE4, it's here. Undo terminal monitor. That is okay. We go next to P02. So P02, we have multiple interfaces, 4 interfaces that we need to configure. Let me see P02, P2 it's here. Undo terminal monitor. Then we paste the configuration commands. The next router to configure should be SBR2. We have 2 interfaces, one to SBR1 and another one to P01. So on SBR2, undo terminal monitor again. That is okay. And finally, we need to do configuration on our RR. This should be RR2. Log into RR2. Undo terminal monitor. System view, sysname, it's RR2. Then I can paste the remaining configurations. That is okay. So we can test the configuration that we have done. If I display IP interface brief, you can see that we are connected to, let me check from P1, P2 because it's in the middle, just to save on time. Display IP interface brief. We have different interfaces. Display IP interface brief again, and then ping 30.30.30.5. This should be .4. It's okay. dot 0, that is okay. Dot 7, not okay, so we can check. And then the final one should be dot 3. Dot 3 is okay, so dot 7 is on RR2. Let's check on RR2. Display IP interface brief. So while you are here, you can see that we have configured on a wrong interface. So I'll do interface gig 0/0/0, display this. Display IP interface brief. We have configured on gig 001 interface, gig 0/0/1. We need to undo IP address. This is how you delete a command on Huawei, quit. Then I will do interface gig 0/0/2. It is IP address 30.30.30.7, mask is 31. So we go back to P1. This should be P2. So on P2, if we try to ping 30.30.30.7, should be able to reach. So this one verify that our IP interface configurations are okay. And it's always best practice to check these basic configurations before you move to advanced configuration, so that you verify everything is okay in this current stage of configuration before you can go ahead and configure other parameters. So the next step, we need to now configure OSPF. So we are also using OSPF in S200. Remember, the two, they don't interact at all, given that they are in different autonomous systems. So we'll start by P2. So on P2, we need to configure OSPF. That is okay. Display this, we are good. We move to P4. So on P4, we are also configuring OSPF. P4, it's here. I'll paste. Quit. Display this. We are good. Next is to configure P02 and advertise the networks. So P2, it's here. I'll paste these configuration commands. Display this. Then we need to configure ASBR2 and activate the necessary networks. So in ASBR2, I'll clear the configuration command. Quit. Display this. Then finally, we need to configure RR2. So I go to RR2. Let me clear the configs, quit, and then paste. So we have finished the OSPF configuration. We also need to verify that our OSPF neighbor relationship is up. So display OSPF peer brief. You can see that we have a peer relationship between RR2 and P01. Display OSPF routing information. You can see that we have different routes that are coming in via OSPF. You try to ping 6.6.6, ping 5.5.5, then ping 4.4.4 on the SBR. That is okay. So we can verify on SBR, display OSPF neighbor. See that we have display OSPF peer brief. You have a peer relationship to P router, and then finally we can do the verification on P router as the display OSPF peer brief. We have multiple SPF sessions, 4 of them. Display IP routing table. You can see that we have OSPF routes coming in. We able to ping 4.4.4, that is on SBR, and then ping 8.8.8, we are okay. And finally on RR2 we need to verify that we are able to, let's just verify again that we are able to ping the two PE routers before we go ahead and implement BGP peering session between them. So the next one is P2. Let's check the IP again. P2, it's 6.6.6. Unknown host. So this one verify that our OSPF configurations in S200 is okay, and we have reachability between different nodes in the same autonomous system. So the next step that we need to do is to now configure MPLS. So for MPLS configuration, it's always required that you configure the MPLS LSR ID, and it's always a best practice that you use the loopback IP because it's always unique. So use the loopback IP to configure the MPLS LSR ID. Once you've configured the LSR ID, you can now go ahead and activate MPLS, MPLS LDP, and also enable MPLS on the interfaces. So the first step, we'll be configuring P1. So P1 is here, system view, and paste the MPLS configurations. That is okay. The next router, it's P3. So on P3, we'll do similar configuration, configure the LSR ID and activate MPLS on the interface facing the P router. On P01, we have multiple interfaces. All the interfaces should be activated with MPLS and MPLS LDP after configuring the LSR ID. So we have P1. Where is P1? P1 is here. System view. Clear the screen and paste. So those are the configurations. Next step is to configure SBR. And when we are configuring the SBR, one important command that we need to add is this LSP trigger BGP label route. So this command, what it does, it enables LDP to allocate labels to label BGP routes. Remember, between the SBR, we need to enable them to exchange label BGP routes. So once we have these label BGP routes coming in, we need to allow LDP to allocate label to this route. Then we'll be able to establish end-to-end LSP path from different PEs in different autonomous systems. So this is a command that you cannot forget to configure when you are configuring option C. So on SBR1, so we'll do a similar command on SBR1. We also need a similar command on SBR2, just to ensure that we have end-to-end LSPs established between the SBRs. We are under the interface. We need to, this one we need to, I'll copy this again. That is okay. And then finally, we need to configure RR1. So RR1 will also configure LSR ID and configure the MPLS on the interface. Okay. So we have finished configuring MPLS and MPLS LDP on routers in S100. We need to do a similar configuration on our routers in S200. So we'll start by configuring P2. So on P2, I'll clear the screen again so that you are able to see clearly what we are doing. The next router to configure is on P4. On P4, configure the LSR ID, configure MPLS on the interface facing the P router. And next it is P02. So P02, we have multiple interfaces also connecting to different nodes. It's like our hub. So P02, I'll paste these commands. Interface gigabit. We have one interface. Let me see. P2300. Let me just verify by displaying the configurations on the router. So I'll display current configurations. 002, 001. So you see when we configure this router, let me say display interface brief. We have 00, 01, and 02. This was for 00, 01, and 02. Let me verify that we have the correct P02. Why is it P02? Display IP interface brief. So it seems we configured on the wrong router. Let me see, P2 display. So on this one we need to configure on P2. So we configured on P2, but this one should be the provider router 02. So let me just reconfigure it on this P2. System view, we have the interfaces best. That is okay. Let's check on our PE provider too, just to verify that we have the correct parameters configured. Display current configuration. It's 66, which is okay. So this is okay. So when you are copying and pasting the configuration, always verify that you are on the right device. Then on SBR2, we also need to configure the LSP trigger command. So on SBR2, it's here. We'll clear system view and then paste our commands. So the same way we did last time, we need to, this LSP trigger command is a global command. So we have it configured, quit. Then the next router that we need to configure is on RR2. So on RR2, system view and then paste the commands. So that is okay. So we have finished configuring MPLS between the different routers. Display MPLS LDP session. can see that we have one session from P1 to the P router. If you check on P router, we also expect display MPLS LDP session. See that we have 3 routers, 3 sessions. This is 1177.10.10, 1177.10.10. We need another session on this router, display MPLS LDP session. We have a session to 4.4. This is in different autonomous systems. So display current configuration. Let's verify our interface configurations on this router. So when you're activating MPLS and LDP, you always have to do it on all the interfaces. You can see that G11 doesn't have LDP configured. So interface gigabit 0/0/1 MPLS LDP. So if I go back to P1, we expect to have 4 sessions. That is how it should be. Let's check on P2. Display MPLS LDP session. We also have 3 sessions. Let's check the configurations on the SBR. Display current configuration. So interface gig 0/0/1, we also need to enable MPLS LDP. Then we expect to have 4 sessions. Yes, that's how it should be. So we have 4 local sessions. And when we now activate and advertise the necessary IPs, we also expect another remote peering session between the PEs in different autonomous systems. That one we'll verify it once we have done the configurations. So the next step, step 7, is to now configure BGP peering session between the SBR. So I mentioned that we are configuring BGP LU session between the 2 SBRs. So this is BGP LU. The label unicast BGP between SBR so that they are able to exchange label routes from the different autonomous systems. So for us to do that, we have to add this command, label route capability, between the 2 routers, and then we'll be advertising the networks. So remember, when we are in these autonomous systems, when we are, let me clear this. When we are in S100, we need to be able to reach the PEs and the RRs in these other autonomous systems. And even when we are in this other autonomous system, we also need to be able to reach the PEs and the RR in the other autonomous system. So that's why when we are configuring BGP at this level, we also advertise the loopback IPs of the PEs and the RRs to the peer AS. So they will be advertised to SBR2. SBR2 will also advertise some prefixes, the loopback IPs to SBR1. So that's why we have the network commands configured on this router. So we'll start by SBR1. So log into SBR1. So that is it. We configure SBR2 and verify that our BGP peering session should be up. I see there is a typo somewhere. We need to change. This is in S200. This one should be in S100. So there is Notepad++. So this one should be in S100. Then I can go back to SBR2, clear my screen. So when you are configuring, always pay attention to the local and the remote AS numbers. So we have done the configurations. So we have enabled the label route capability, display BGP peer. It will take some time. Let's check whether we are able to ping the point-to-point 172.200.200.0. Can see that we are not able to ping the point-to-point between the two routers, so we need to troubleshoot and establish why we are not able to ping the point-to-point between the routers. So one thing that we can do, let's first verify that we have the right IP addresses configured. Display IP interface brief. Yeah, you see that we have configured a wrong IP address on gig 00. So I'll rectify that. Gig 0/0/0 IP address 172.200.200.1 mask is 31. I'll do the same on SBR1. Verify the point-to-point IP. Display IP interface brief. Quit. You can see wrong IP address configured, interface gig 0/0. So these are some of the things that you need to be able to identify and correct when you are configuring. It's never that smooth. There is always a point of troubleshooting some things. So we are good, and you can see that our BGP peering session is up. Display BGP peer. If you do 172.200.1 bubbles, you can get more details about this BGP peering session. Advertised and received. You can see that label, unicast label, advertised and received. Let's verify that we are able to get the route. So if I display BGP peer, BGP routing table, peer 172.200.200.1, received routes. You can see that we are getting these prefixes from the other peer. We can also check on the advertised routes. We are able to advertise these routes to the peer. So we have, if I display BGP routing table, we expect to have these routes in our routing table. Similarly, I can verify that on SBR1, on SBR2, we should have similar output. Display BGP routing table. You see that we have the routes. Display BGP routing table. Peer should be 172.200.200.0. Advertised routes. Those are the advertised routes. You can check received routes. So you have the routes. So we have advertised the routes, we are able to receive them. So the next step of our configuration is to now ensure that these routes have their labeled routes, and then we also have routes import from BGP to OSPF, because remember we have an iBGP between within the autonomous system. So if I check on P2, display IP routing table, for example 7.7.7, the IP for RR1, we don't have that IP. Similarly, if I were on RR1 and I try to check display IP routing table 8.8.8, you can see that we don't have this route. So we need to do some route import from BGP to OSPF. So the first thing that we need to do is to configure some prefixes. Remember, we are only importing these loopback IPs from BGP to OSPF. So this is what we are doing with these prefixes. And then once we have done that, we have a policy to apply labels. Remember, this is BGP label unicast between the SBR. So we need to configure this policy so that when we are exporting routes, we are applying labels on it. They are label routes. And then we need to import BGP routes to SPF using this route policy, import loopbacks. So on router 2, we'll do the same. Let's start with SBR1 and verify that we have the routes. So on SBR1, let me expand this SBR1, clear the screen again. So now we have advertised routes to OSPF. If we go back to RR1 and display 8.8, you can see that now we have the route and it's coming through OSPF. We do the same configuration on SBR2. So on SBR2, clear the screen again. We can check. So this one we need to be under BGP 200. That's why I always disable the monitor. BGP 200, we need to rerun this command. Display this. So we are set. Let me check on RR2 whether we have the routes. RR2 display IP routing table 7.7.7. The IP for RR1. Let's try to ping to see whether we have reachability between the RRs. So ping, when you want to ping, you always have to source. So it's 8.8, then 7.7.7. We have communication between the RRs. So that is clear that our configuration is okay. We can try to ping the PEs in the other autonomous system 1.1. We are able to. Let's try to ping 10.10. So once we have reachability between the RRs and also between the PEs, we can now go ahead and do further configurations. We can now configure MP-BGP peering session between the RRs, and these are the configurations. So at this stage, we have BGP 100, we are peering to RR in AS200. This is 8.8.8. Then you need to undo the policy VPN target. Remember, when you do the policy VPN target, it means the RR will have to check the VPN targets. But remember, when we are doing option C, we are not configuring VPN instances on the RR. So that's why we need to undo the policy VPN targets. So I'll start with RR1, system view. I'll paste. Display this. We can also configure the router ID 8.8.8. This one should be 7.7. So display this. And then we'll go ahead and configure RR2. So on RR2 system view, we apply the configurations. We'll also configure the router ID to be 8.8.8. Display this. We are okay so far. Display BGP VPN v4 all peer. So you can see that it will take some time to establish. Let's wait for the counter to expire. Now in the connect stage, so if you have configured eBGP using the loopback IPs, you will realize that we are having an issue here. The BGP is not coming up. And when we go back to this topology, remember for eBGP session, it only supports one hop. But when you check this RR to this RR, there are multiple hops away. You can see that this one is hop 1, kind of, hop 2, hop 3, hop 4, hop 5. So there are multiple hops that it has to traverse before it establishes the BGP peering session. So that's why we need to add another command on the RRs for us to be able to establish the BGP peering session. If you just do it the way you have done, it will never come up. So if you check this configuration, we need to add another command. So I'll do peer 7.7.7 EBGP max hop. We can put it to 10 depending on the size of your network. On RR1, I'll do peer 8.8.8 EBGP max hop 10. Display these. Now we expect the peering session to come up. Display BGP VPN v4 all peer. It's idle. We'll need to give it some more time. So always remember the key thing that you need to check, especially for eBGP, the maximum number of hops that are supported. So if you don't do that, and we are using loopback 0 IP, so our peering session is now up. So on RR1, RR2, we can also verify that our peering session is up. Display BGP VPN v4 all peer. You can see that we have a peering session between RR1 and RR2. So we have a peering session, MP-BGP VPN v4 peering between the RRs. So the next step that now we need to do is to configure BGP peering sessions between RRs and the PEs. So we need two BGP peering sessions. That is the next step of configuration. Configure MP-BGP session between RRs and PEs. We are also configuring them as the reflect clients, so they will be clients to the RRs, and then we are next hop invariable. So when we are doing option C, we don't want the RR to change the next hop. Remember, the PEs are reachable from each other, so that's why we need to configure the next hop invariable, so that when this router is advertising the routes, it will not change the next hop of the routes. It will just advertise the way they are. If the route is from a PE2, the next hop should remain to be PE2. So this is for RR1. So on RR1, I'll paste. And then we can check for RR2. This is for P2, P1, P1 that is. So P1, we need to configure a peering session towards the RR. Let me open P1. P1 is here. Let me clear the screen again. That is it for P1. And then P2. This is P3 because we are in S100. I paste the configurations. On the RR, we can verify whether our peering sessions are up. So on RR1, display BGP VPN v4 all peer. See that we have one session that is already up. We are still waiting for another session to come up. 10.10.10. It will also come up in a few. It's now up, so we have BGP peering session established between our PE routers and the route reflector. So we need to do similar configuration in S200. So in S200, we'll establish BGP peering session from the RRs to the PEs. So on RR2, I'll paste this. Display this again. And finally, we need to configure the PEs. So for PEs, I will configure them one by one so that you get to understand how to configure it step by step also. So we'll start by P2. Looking for P2. P2 is here. Display current configuration. We don't have any BGP configuration, so it is BGP 200. We need to run the command peer. It is 6.6. This is 8.8.8. AS number it's 200. Peer 8.8. Connect interface should be loopback 0. And then IPv4 family unicast, undo peer 8.8 enable. Then we need to configure IPv4 family VPN v4 peer 8.8 enable. Display this. So this is it. We do the same configuration on P4. It is BGP 200. PI it's 8.8.8. AS number it's 200. Can recall the same command, connect interface loopback 0. Display this. We need to IPv4 family unicast. We will undo peer 8.8.8 enable. Then IPv4 family VPN v4. We need to peer 8.8.8 enable. Let's go back to our RR. Display BGP VPN v4 all peer. We wait for this one session to come up. Now it's up, so we have our RR to PE peering sessions, IBGP sessions, and we have configured the RR as the route reflector. You can see that route reflector client, and next hop invariable. So the next step is to now go ahead and configure VPN instances on P1, P2, P3, and P4. So we have mentioned that for the route target, they will be globally unique, so you cannot have same VRF targets for different VPNs because they are globally unique. So you need to configure it end to end. It should be the same. So on P1, I need to configure the 2 VPN instances. Quit. Can display current configuration. Configuration VPN instance. You can see that we have the 2 VPN instances configured. I'll configure VPNs on P2. So on P2, quit, configure the VPN instances, display current configuration, VPN instance. That is okay. And now we do on P3. So on P3, we'll do the configuration for VPN instance. That is okay. And finally on P4. So I'm just setting up different route distinguishers. P4, where is P4? It's here. So we have finished configuring the VPN instances. And remember, we don't do VPN configurations on the ASBR and also the RRs and the Ps. We only configure on the P routers. So the 4 P routers are configured with VPN instances. The next step is to now configure the interface facing the customer and bind the VPN instances. So we are configuring interface GE001 IP binding VPN instance and then assigning the necessary IP addresses. So on P1, we need to configure these two interfaces facing the customer CE device. So P1, I'll paste this, quit, and go ahead and do configuration on P2. P2 also has two interfaces. So this is P2. Then we need to check P4, P3, only one interface. So P3. I'll paste this, that is okay. And finally on P4. So P4 we also have one interface. P4 only one interface facing the customer, that is okay. If I display this, you can see that we have the VPN instance configured and an IP address assigned. So the next step is to now configure BGP peering between the PEs and CEs, starting with the PEs. So we have VPN instance peering, VRF peering between the PEs and CEs. So we are using BGP as our PE-CE routing protocol. So you can see that in this, on P1, we have one in VPN A and another one in VPN B. So I'll start by configuring P1. These are the configs for P1, and then next to P2. P2 should be in S200. Always remember to verify the S numbers. So I'll do BGP 200, then paste the remaining commands. Next is to configure our P3. P3 should be in S100. So it is BGP 100, and then I paste the commands, quit. And finally P4 in S200. Open P4 again, quit. So that is it for VPN for PE-CE peering configuration. Now the final step is to now configure our CEs, and once we have configured our CEs, we can confirm that our PE-CE routing protocol is okay. And when we are configuring the CEs, we'll be advertising the loopback IP so that we can test reachability. So that's why you can see that network 11.11.11 is advertised in BGP. So I'll start with C1. We configure all of them and then we can verify. C1, system view, and I paste. That is okay. C2, so we are just configuring the loopback IP and the point-to-point connection between the two devices, PE and CE. C2, then once we are done, we'll verify our BGP peering sessions and troubleshoot anything that is not up. On C3, this one should be C3. C3, it's here. C4, configure C4, 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 where is C4? System view and then paste. C5 and C6. C5. C5, it's here. Then finally C6. So we have finished configuring the CEs. Let's try and verify that our peering sessions between the CE and the P are up. So if I display BGP peer, you can see that our peering session is up. On CE2, let's check the same. CE2 display BGP. The BGP peer, it's up. C3 display BGP peer, it's still idle, so we need to check why it's still idle. C3 display this. C3, where is C3? See, there is some configuration error in terms of the autonomous system number, so we should undo peer 192.168.0.0, and then we can reconfigure peer 192.168. S number should be 100. Display this. That should be okay. Let's wait for it to come up on CE4. Display BGP peer. C4, it's in S200, so let me clear the screen first. Display this. It should undo peer 192.168.1.4, then configure peer 192.168.1.4. S number should be 200. Let's go back to C3 and see whether our neighbor relationship is up. C3, where is C3? It's here. You see that we have an established BGP peer. Display BGP peer. We have an established BGP peer. C5. Display BGP peer. This is S200. Where is C5 on our topology? So this is C5 0.4. It is 65003. Okay, then let's try to ping the point-to-point 192.168.0.4. It's able to reach. Let's verify the configuration on our PE. Where is the PE router? The P1, P1, P1. P1, it's here. Display current configuration, configuration BGP. This is the command that you can use to see your BGP configurations. So that is 0.5, AS number is 65003, looks okay. VPN B. Display BGP VPN v4. All peer. We have 0.5 not established yet, 65003. P1 and C5. Let's check the configurations again. So this one, we have configured the wrong peer. These are some small issues that you always have to pay attention to when you are configuring your routers. The interface IP is the peer IP is 192.168.0.5. Then I will do peer 192.168.0.4. AS number should be 100. We give it some time. Let's check on C6, C4, C4 first, C4 not yet. Display this. Display BGP, VPN, BGP peer. This is still idle also. Let's check on P3. So on P3, display BGP, VPN v4, all peer. That is okay. We need to check on P4. Display this 1.5. Then we are configuring 65006. Let's verify that that should be 65005. So it is IPv4 family VPN instance, VPN A. I will undo peer. One 92.168.1.5. Do peer 192.168.1.5. AS number should be 65005. Display this. That one looks okay. Let's confirm C6. Display this 65006. The peer should be 1.2. AS number should be 200. Undo peer 192.168.1.2. Then we'll do peer 192.168.1. Hope you're able to see it clearly. .1.2. AS number should be 200. So display this should be okay. Let's verify that our C4, the peer relationship, is now established. That looks okay. Display BGP peer. That is okay. C5, we also have it established. Display BGP peer. We also have it established. C6. And that is pending. It's BGP peer. Yes, give it some time to see whether it will come up. Let's check on P2 again. P2, display current configuration. Configuration BGP. So you can see that here 1.1 P2 0.5. This should be P1. Let me see. P1 0.5, P2. P1, do we have the peer relationship up? Display BGP. VPN v4 all peer. So on P2 we have a problem. BGP 200, IPv4 family, VPN instance, VPN B. I will undo peer 192.168.0.5 and configure the right peer 192.168.1.3. S number should be 65006. Display this. Let's wait and see whether it comes up. Hopefully it will come up. Let's also verify the configuration on this router. Display this 65006. That looks okay. 1.2. The other one we have configured 1.3. So display BGP VPN v4 all peer. Let's give it some time, 30 seconds. Yeah, it's now up. So we have our BGP peering sessions up. From the topology, we can... So we have BGP peering sessions end to end. We have BGP peering session from PE to the CE, from the PE to the RR, and from the RR to the RR in the other cluster, RR to the PE, and RR to the CE. So we have all these sessions, BGP sessions up. And now we can verify our routing tables. So I'll start by P1. On P1, if I display BGP VPN v4 all routing table, you can see that we are getting the routes. We have these customer routes. Remember these loopbacks 11.11, 22, 22, 44, 67, 66, 77. They are all coming from the user side. And you can see that the next hop is not changing. It's still using the loopback IP. Let me see this one, 8.8. P1 should not be changing the next hop. Let's see if I do on C1 display IP routing table. You can see that we have these prefixes 11.11, 22.22. If I do ping -a, the local IP is 11.11, and then I do 22.22.22. we are able to ping. So we are able to send our traffic all the way from C1 to C2 over the BGP session that we have established. Let me verify on RR. I need to verify something here. Display current configuration, configuration BGP. So we have 10.10, we have so whenever the RR is advertising the route, you'll also not change the next hops. So I'll do BGP 200. Because when we checked on P1, you can see that P1, the next hop is pointing to 8.8.8, which is wrong. It should be pointing to 6.6.6. So that is something that we need to change. I'll do IPv4 family, VPN v4. Then we'll do peer 7.7.7, next hop in variable. On RR1, we also need to do the same. What the other are, so it is BGP 100, peer 8, which will be in IPv4, VPN v4 peering. Then it's peer 8.8.8, next hop in variable. That is okay. Let's check on P1 again. Coming from 8.8, yes, now you can see that the next hop is set to 86.6.6. So the RR should not change the next hop whenever it's advertising the routes. When we go to C1, we still should be able to ping from C1 to C2. Also from C5 can display IP routing table. Can see that we are getting 66.66, ping -a 33, the local IP .33.33.33, which will be able to ping 66.66.66.66. We are able to. From the upper PE, we should also be able to ping quit display IP routing table. You can see that we have the routes. If I try to ping -a, this is 44.44.44. I will ping the IPs in the same block, 11.11.11.11. Not going through. That one can be checked later. Let me try to ping the 177. This is on C4, 77.77. 77 not going through. So we have the routes, but we are not able to ping. It could be that we have missed something connecting to P4. Let me check P4. Display current configuration. So on P4, P4001, we have MPLS, we have MPLS LDP enabled. So this one, the problem is this. We need to be IPv4 family, VPN v4, and then I will. Now this one uses the policy VPN target, which is okay. Let me check on P3, display BGP VPN v4, all routing table. So we have the routes, the next hop for 77.77, the next hop is pointing to 9.9.9, which is okay. C4, display BGP peer. The peer is established. Display IP routing table. 11.11, it's there. Let me try to ping the next hop. It's pointing to 192.168.1.4, which is okay. Ping -A, this is C4. C4 has 77.77.77.77. Try to ping 11.11.11.11. It's reachable. Try to ping the local AS 22.22.22. That is okay. So it confirmed that our traffic forwarding is okay. Let's check on C3 again. C3, why is it labeled P3? C4. Display IP routing table. For this one, try to ping -A, C3. This one should be 44.44.44.44. Try to ping 77.77. So it's okay. So this one verified that our communication is okay, and we are able to use option C to advertise the routes between the different autonomous systems. On these RRs, we can also verify that if I display BGP VPN v4 all routing table, you can see that we are learning these routes in our routing table. On RR1, we also have the same display BGP VPN v4 all routing table. You see that we have the routes. So whenever we are forwarding the routes from one AS to the other, the route has to come from the CE, from CE to PE. And of course, PE will advertise the route to the RR. RR will advertise the route to the RR clients and also to the remote RR. So when the route is on the remote RR, it will advertise the route to the local PEs, and then the local PE will advertise to the CE routers depending on the route targets that we have set on our routing table, on our configurations. So this is how simple it is. The routing, the implementation, it's very simple. You just need to pay attention on the basic details. For example, if I were to come on this interface G001, interface gig 0/0/1, and I forget to configure MPLS LDP, our traffic will not flow through the network. So C1, remember we were able to ping before. Let's try to see if we can ping again. So you can see that our ping has failed. It cannot go through. We could be having the route, yes. Let's check on P1. Display IP routing, display BGP VPN v4, all routing table. You can see that yes, we have this, but it's not installed in our routing table because it will not have the necessary information. But once we activate MPLS LDP on this router, we should be able to ping again from C1 to C2. So it works. So Just small misconfiguration of missing MPLS or MPLS LDP on an interface will take you a lot of time to troubleshoot. So when you are doing the configuration, always pay attention to the small details. Ensure that you configure the right IP address, ensure that you enable MPLS, ensure that you have enabled things like BGP max hop, the next hop invariable. All those details should be configured correctly. The route targets that will control the route import between the different autonomous systems. And that is it. That is how you implement option C with route reflectors. Of course, we can have multiple route reflectors. Remember, in this setup, we only have one route reflector, RR1 and RR2. But for the redundance of the network, we can still go ahead and add another route reflector in this cluster so that we have two route reflectors. Whenever there is one that is down, this one will be able to advertise the routes. And then we can also have a second route reflector in this cluster so that they are redundant. And that is how we improve the network redundancy. So that is it, guys. I hope you've enjoyed this session. I know you've requested for it for many times, but now we have it on our channel. And if you have any question when you are doing the implementation in your lab, feel free to reach out, feel free to ping me, and I will be glad to help you to ensure that you are able to set a similar lab and do the lab simulations. Just a reminder that if you have not subscribed to our channel, kindly subscribe to our channel and stay tuned in for more upcoming videos. Thank you and see you in our next episode. Bye.